Okay, welcome back, my fellow engineers. Let's move on to our next topic here, which is continuing our discussion about using pointers and addresses. And we're going to apply this in the context of functions and cover two really important essential topics, which is PassByValue and PassByPointer. Now, this is a topic that you probably recall we have seen before, slightly different context. Okay, we want to take these concepts that we've previously introduced, but go a little bit further with them and look at them in the context of using pointers, go a little bit more thoroughly into applying the knowledge of addresses, and looking and actually tracing some code to see how these concepts relate, and how they can be used for some pretty powerful ways of solving problems. Okay, so just to kind of clarify a bit, when we're talking about PassByPointer versus PassByReference, when we talk about PassByValue versus PassByPointer, these are two different ways of sending information into functions. Okay. I also want to point out that PassByPointer, a lot of times you hear people refer to this as PassByReference. There's some minor differences between PassByPointer and PassByReferences. For the sake of argument and in the context of this course instruction, we're going to really refer to them as the same thing. I think that's an important thing to point out because later on, other courses down the road in your career, you might hear people referring to PassByReference, okay? And for the sake of this class, I'm going to try to use the term PassByPointer, okay? All right, so these are two different ways of sending information into functions, all right? Okay, this doesn't really become super clear until we look at this in the context of actually seeing some real examples. So let's go ahead and do that, okay? So here's our first example, using PassByValue. And what we see here is, let's look on the left-hand side, and there's a small little code snippet. And we've got down in the main function here, we have a variable, an integer, variable a, setting to 5, and we're passing that variable into a function called foo. Okay, foo is, our function here is taking in a parameter called, giving a name of b. Okay, and what we see here is that what that does with PassByValue is we're making a copy of the original value. Right, so we can look here on the right-hand side. What we're seeing here is that we basically have variable b gets the value of variable a. So what this does in this context of this code is it's saying, all right, variable b is assigned the value of a. Okay, key thing here, two different memory locations. Okay, we're making a copy, two different locations in the computer memory in which those variables are stored. Right, so if we see these addresses here, for the sake of argument, we could have address 1 here on the left, okay, representing the location of variable a, and then we have a different address for our variable b. In this case, we're saying 2. Okay, we're just making those addresses up. Is a different copy of that primitive value. Okay, primitive is what we're referring to as our data type primitives that we discussed earlier in the course. Data type primitives being things like integers, doubles, all these different basic built-in data types that are built into the C language. Okay, so let me summarize. Right, PassByValue, okay, making a copy of the original value. Okay, remember the scope. If we had function foo, a lot of times it might, you can build this where it has the same name. It might also, instead of b, we could have a situation in which we actually called that variable a. So we have two variable a's, but they're different scopes, so that would be acceptable. Okay. So let's take this a little bit further. Let's look at another example. Okay, let's look at a little bit more of a thorough example, and let's trace out what's going on. Okay. So we've seen this example previously, but I think it's worth rehashing and kind of recapping it a little bit. And this, I think the reason I really dwell on this example is that it's such a common mistake for people to make. And what we have here is we have a function called add1 that literally, here's the kind of key thing, is it does nothing. Right? We have the main function here, x, setting it to 5. We call function add1. Add1, x, adds 1 to it, okay, and then returns nothing. Okay, and the key thing here is, let me run it and then we'll kind of explain what we have in this case. Okay, I'm going to compile that code. I'm going to run it. Okay, and we see that x is 5, right? X is 5. Well, why is that the case? Why is x 5? Well, x is 5 here for the following reason. Okay, let me have a little space to write, but we're looking at this code. The reason x is 5 is because of the following scenario. What we have is a situation in which we have our main function stores variable x that equals 5. Okay. Then we have our function add1, okay, and it is assigned a copy of that original value, okay, which is which of course is 5. We add 1 to that and make it 6. However, the moment add1 returns, the moment that function returns, this data here in that function scope is freed. All right, and the copy that we're printing is going to be this value here. Okay, the copy that's printed to the screen. Okay, that's an important thing to note. It is something we've seen before. I think it's critical though that we look at that and say we have a firm understanding of what that's doing and why before we kind of move forward. Okay. So now let's take a look at another example that traces it, where we can see some addresses and pointers and what's going on a little bit more thoroughly. Okay, so let's take a look at another example here, and let's first take a moment and just take in what we're looking at on the screen. Okay, what we're looking at on the screen here is we've got these, we have a variable var set to 5, okay, and we have an integer pointer that is pointing to the address of var. Okay, so in other words, it's doing the following. Okay, we've got we've got two variables. Okay, we have var, which is an integer, the value being 5. Okay, and then we have pointer, which is an integer pointer, and it's going to point to that address. Okay, it's going to point to that address. That's what we've seen so far. Okay, hence this is what makes that assignment. The value of pointer is the address of var. Okay, so what we're seeing here is we're going to print a bunch of things to the screen. We're going to print the address of var. We're going to print it first from the context of the main function. Okay, and you know what? I'm going to make this a little bit more clear. I'm going to say from main. Okay, and then we're also going to print the address of num from our foo function. Okay, the address and the value. So notice, we're passing in var by PassByValue. We're going to assign num to be that value, okay? And we're going to print out a bunch of addresses and the values of both. So the address of num, value of num, okay? And let's go ahead and let's run this, and then let's talk about what's going on. Okay. So I'm going to compile this code here. Run it, and what we're getting is we've got a bunch of addresses that are being printed to the screen. Let's take a look at them. Okay, so I want you to notice a couple of key things here. Right? First, notice the address of var is the same as the value of pointer. Okay? The other thing is, notice that the address of num is different than the address of var. Okay? So what we can do is we can draw this. Okay, let's go ahead and draw this out. Okay, and if we draw this, and we're going to use the real addresses that we ran here in our example, the address of var, I'm going to just use the last two digits, is 6C. Notice all the values are in hex. So we know that the address of var is this address 6C. Okay, so these are our addresses. Okay, and then the address of num is different. Okay, the address of num is not 6C, it's 4C. So we have a different value. Oops, 4C, which is our num variable. Okay. Now we know that that value here is also going to be 5 because we make a copy. Okay, we're making a copy of this. We are copying that value to a different memory location. Okay. That's the key idea, is we are copying that value to a different memory location. Okay. So this is our setup here. We've got 3 different variables. We've got an integer pointer called ptr, we have an integer called var, and we have an integer called num. Okay. Different memory locations for each one of those. Okay. The value of pointer, is 6C because it points to the address location of var. Okay, so that's our setup. Okay, now let's see why we got those results that we received in this case. Okay, and one of the key things here to note, right, just setting this up, is that if we change this down here, right, at any point, if we change the value of something, oops, if we change this value down here to something else, okay, we are not affecting the original variable because it's in a different memory location. Okay, so that's a key idea when we're looking at PassByValue. Okay, this is still PassByValue. Okay. All right. So here, that's a recap of looking at PassByValue, and I want to point out a couple things here. For one, take a look at the addresses in this case, and if I rerun this multiple times, right, I'm going to re-execute this. Notice that the second time I ran it, the memory address has changed. Okay? You do not have control over what addresses are going to get assigned. Okay? That is outside your control. So you cannot assume they're going to be in the same memory location every time you run it. Sometimes if you're using an IDE or something, you might end up getting the same ones, like NetBeans, interactive development environment. However, by and large, notice every single time I ran this, I got a different memory address assigned, okay, outside your control. Okay, let's take this a step further now. Let's look at an example of PassByPointer. Okay. Key thing with PassByPointer is we're using this one single copy of the original data. Okay. So here's an example. We look at the code on the left, right? Notice that B is a integer pointer. It means that if the address that's stored in B, if we go to that address, it's an integer, is the value that's going to be stored there. Okay. And what we see here, right, is that both B, which is an integer pointer, and A, which is an integer pointer, point to the same memory location. Okay. They point to the same memory location. Okay. In this case, the same memory location stores a value and that value that is stored there happens to be 5. Okay, happens to be 5 based on how this example was defined. Okay. All right, so PassByValue, we're making a copy, 2 different memory locations, PassByPointer, 1 single memory location. All right, so let's look at an example of this. Okay. Going to that add 1 example that we were looking at previously, big difference here is notice that x in the add 1 function is an integer pointer, different data type. Okay. We are using the dereference operator. We're using the dereference operator when we are using x. Okay, meaning go to the memory location that x points to and operate on that location. Okay. Star x is 5, is the value 5. Okay. You should be able to see that by looking at the example. Star x is value 5. Okay. So in this case, the result is different. It's not going to print 5. Let's go ahead and let's run this. Okay. Notice that we got 6. Okay. Notice that we got 6. Here's the reason. Okay. Here's the reason why. We received 6 in this case because what we had going on was the following scenario. We have main, okay, and our main has an integer called x. So our main has an integer called x, which has value 5. Okay, and our function add1 has an integer pointer also called x, right? I did that intentionally just to kind of show you a lot of times things can be named the same thing, right? To show that we're really dealing with different data types here. Okay. And this x is a pointer that points to this memory location. Okay. So to get to, if I just said x, keep in mind, if I just said x, I'm referring to this spot here. Okay, and if I'm in the add1 function scope and I reference x, right, x refers to this in the add1 function scope, okay, where star x in the add1 function scope refers to this, okay, refers to the value 5. Okay, key difference, all right. So now when I say star x equals star x plus 1, I'm referencing this memory location and it gets the value 6. Okay? All right. That is why that result, why this example here gives us the result that we happen to see. Okay? And this has some, so we can pass in a same memory location to operate on one single version of it. And this is important, as we've seen previously, particularly when it relates to how we are dealing with arrays and hence strings. Okay? So if we look at, say, arrays are going to have some very specific, or arrays we know, anytime we're dealing with arrays, are always PassByPointer. Always PassByPointer. Okay? And so this example here, we look at this example, all I'm doing is I'm creating an array of size 5, and I'm printing out all of the addresses of all the different index of the array, both in the main function scope, okay, as well as in the foo function scope. Okay, I'm calling it array in the main function scope, and I'm calling it array2 in the foo function scope. Okay. Now when I run this, what we're going to see is all of the addresses are identical. Okay? All of the addresses are identical. So I'm going to come here, let me go ahead and run this just to show it to you. And notice that all of the addresses are identical whether they are in the main function scope or the function scope. Okay? Meaning we are operating on the same copy of the original array. Okay? Another key thing to notice is that if I'm just referencing the name of the array, okay, just referencing the name of the array, I get the address. Okay, I get the address of the very beginning of the array. Okay, so that is what's actually getting passed into a function. Okay? When you call a function with an array, you are passing in the address of the start of the array. Okay, that is the only information that needs to get passed in. Okay. We'll practice that. We're going to go a little further with this. Okay, video's getting a little long. I want to stop it here and let us kind of expand on this at a later time. Okay. I encourage you to rewatch, go through it, make sure you understand this, and then we'll build upon it in subsequent lessons. Okay. Thanks for watching, and I'll talk to you soon.